Okay, so for number 7, it's set to simplified and factor. So with this one, simplified and then factor. So I have to actually expand it out first. This one right here, 2x plus 3 squared, is not just 4x squared plus 9. You actually have to write it out. It's 2 binomials multiplied together. How do you multiply 2 binomials? What method do we use? FOIL, right? So it's not just square this, square that. It's FOIL. So there is a middle term right here, the 12x, after you expand it out. Same thing right here. You have the 3 times another 2 binomials. So what I like to do is I like to do the FOIL first, and then times the negative 3 in afterwards. Arian, critique? Yeah, thank you. It's louder than you think. Okay, so after you after you distribute that negative 3 into everything in the second bracket, you have these, and then you collect like terms. And then you get this. Okay? If you check, take another 30 seconds to check if this is factorable, because the question does say simplified and factor. But looking at this, nothing else, no common factor, no trinomial factor possible. So that's your final answer. Yeah.
Is there a way to check to see if it's factorable without going through combinations?
No shortcut. No shortcut with this. Well, actually, there is a shortcut. You could do quadratic formula. If you get a whole number, then you know it is factorable. Yeah. But if you get a decimal, then it's not. So that's a little shortcut that I guess you could check. Yeah, it's a long cut, but at least it's a way for you to check. Okay. Yeah. Okay, and then this right here, notice the difference in the question. This one says solve. So if it says solve, what's my final answer going to be? X equal, right? When it says solve, it means your final answer should be x equal, not just factor. So rearranging all of this to one side, looking at this, I can do common factor. You should always do common factor first. Looking at all 3 terms, the common factor is 2x. So I'm factoring the 2x out and dividing each of the term by 2x. When I do that, I get 2x squared minus 3x minus 14. All right, it's a trinomial with a square, so I can do this cross-multiply method. 2x squared, break it up, it's 2x times x. Negative 14, I can break it down into negative 7 and times 2. So when I cross-multiply, I get that negative 3x, my middle term. So that means that works. I'm going to write this as my first binomial and this as my second binomial. When you write that, don't forget that 2x is still there. So carry that down. Right? If you went to this step and stopped, you factored, but you never answered the question. So because it says solve, you have to do the arrows. Okay, set this to 0, set this to 0, set this to 0, and then solve for x in each of the condition. So that means you have 3 answers in this question. X could be 0, x could be 7 over 2, or x could be negative 2. Okay. Yeah. Right. If we were looking at this originally, we can't do this method because this is a cubic relation. So that's like also kind of your hint that, oh, I can probably factor out an x to make it a quadratic. Yeah. The 3? Yeah, exactly. Yeah, that's right.
Where's the third x?
The 2x. Yeah. Okay, so since it's a cubic, you know there's 3 x values. Okay. And also, if let's say you didn't do this part, you did the quadratic formula, you could get these 2 answers as well. Okay, and that's why the name quadratic equation, quadratic formula. make the connection. So quadratic formula works on quadratic equations, not cubic. Okay. And then this one was a little tricky. Tickets to a school band cost $5. And then if it's $5, 300 people will go. But then for every 50 cents increase in price, 20 less people will go. So find what ticket price would generate a revenue of $1,562.50. So the difference in this question and the ones that we are used to doing is it will the one that we're used to doing will say what ticket price would generate a maximum revenue. But this one, it gives you a specific dollar amount, and I want to know the price that gave you this amount. So that's why it's a little different. How you set it up is still the same. We did a ton of questions like this with the increase and decrease and stuff. So normally, if it was just a regular question where it asks you for revenue, you'll just do price times the number of tickets. Right? That's how we calculate revenue always. But now, instead of $5, I'm adding a 50 cents increase for every 50 cents increase. So that's why I have the X right here. And for every 50 cents increase, instead of 300 people, 20 less is going to count. So that's why I have the minus 20x and the plus 50 cents x right here. Without the x, I'm not going to get my quadratic formula. So make sure you have that. Remember, your x is the number of increases, not the cost of the tickets, not the number of people, but number of increases that you're going to do. Number of 50 cents increase. Right, so I have my equation right here, okay? And so looking at this binomial times another binomial, you know you're supposed to expand it out. So expanding it out, but again, I tell you what revenue I want. I want that 1,562. So I replace that with the R. Instead of setting it to 0 and finding the maximum, I'm actually looking for R right here. So when I expand it out, move everything to one side, I get this quadratic, so I can use the quadratic formula. When I use the quadratic formula and sub in the A, B, and C, I get x is 2.5.
Wait, can you read the equation out loud? Because the
last
part.
At 10x squared minus 50x plus 62.50 equals 0. Yeah, it's a little messy because on Friday afternoon I couldn't add or subtract, so then I made some mistakes, and then the students corrected me. Yeah. So I got x equals 2.5. What does that mean? What does x equals 2.5 mean? Yeah. Not price reduction. Price increase, right? So increase the price 2.5 times. Yeah. So remember the question was asking what ticket price would generate this amount. So this was your ticket price, $5 plus 50 cents times X. So if you sub in 2.5 for X, that means the price that I should set the concert ticket to should be $6.25. Okay. If you did your math correctly, if you sub in 2.5 here, 2.5 here, you should get 1,562. Okay. So $6.25 is the cost of the ticket. Find the y-intercept. Well, remember y-intercept is just the when x is 0. So in this standard form, your y-intercept is just a 62.50. Now, in this case, it actually doesn't make much sense to ask you to graph the relation because we're not really calculating the maximum. Like we're not doing maximum value. We're just basing off this. So I can show you what the graph looks like. It just looks something like this. But notice instead of a parabola that opens downwards, it's just a parabola like this. because again, it's not asking you for maximum or minimum profit. It was just asking you to solve for this point right here, the 2.5. Okay. So on the exam, the graph doesn't make sense.
Wait, it could have made infinite profit. Because the problem opens infinitely upwards.
Yeah,
But they chose to make,
1,500
they
only.
could have made infinite revenue.
They chose to limit their potentials. Yes. Okay, so that's the answer for this question right here. But again, more likely you'll see a question that asks you for maximum or minimum profit on the final exam. Okay, because then the graph will be more meaningful. Okay, next, this one. Right, the path of a rocket is modeled by the equation this, where h is the height, t is the time since its launch. What is the maximum height of the rocket, and when does it reach the maximum height? Okay, so notice this keyword, maximum. Whenever you see the word maximum, what comes to mind? Vertex, yes. And to find vertex, what method do you have to do?
Complete the square.
Complete the square. Yeah, complete the square. So this is like in English. What does this imply? Maximum implies that it's vertex, so it implies that you have to do complete the square. So here, given the standard form, so you can be sure that you'll be asked to do complete the square on the exam. It's one of the most important things that you need to learn in the grade 10 course. The complete the square and quadratic formula. There's 2 questions there for you. Okay, so complete the square. Factor out the a term in the first 2 terms. Factor out the a in the first 2 terms. So t squared minus 4t. All right, when I divide then 12t by negative 3, I get negative 4t. Be very careful with the signs. Second step, write that on the side. So the b term divided by 2 square. So you get negative 2 square, which is 4. Okay, so t squared minus 4t plus 4 minus 4. H equals negative 3. Now I can factor this part. Okay, and my factor is going to be this number right here. That's why I always write this on the side to remind myself. So t minus 2 squared. Bring the 4th term out by multiplying it with the a value. So negative 3 times negative 4 is positive 12. So you get that. So h equals negative 3 t minus 2 squared plus 41. Okay. So what's my vertex?
41.
Did I make a mistake? Did I make a mistake? Did you? Yeah. But I heard Catherine say 41. That made me...
No, I meant 41 as an exclamation.
Oh, 41, not 41? Okay. When I heard that, I got a little scared. I was like, uh-oh. Am I not doing my math correctly on a Monday morning? So I found my vertex now to actually answer the question, because there was a 2-part question in this.
Did you get the in the question?
It didn't. I should. On the final exam, I think we did give units. Okay, so let's just say meters and seconds. Okay, let's just say, so that our sentence makes is more meaningful. Therefore, the rocket What? Reach maximum height 41 meters
2 seconds
after 2 seconds.
Technically, they never
Well,
told
they didn't
you.
say the units.
I know. I just threw in the units so that our sentence makes more meaning.
The reason to it that it's meters in seconds.
On the exam, it will say. Yeah, on the exam, it will say the units. All right. So this was not a hard question. It's all it is. It was just completing the square, and you answered both questions with one coordinate. Okay. If I were to sketch it, it will look something like this. What's my y-intercept? Yeah, 29. Remember, this is your center form, so this is your y-intercept. So 29, 2, 41, and then so I could ask you how high is that platform of when or I could say Kelly was standing on a hill when she launched that rocket. How high was that hill? And then it will be 29 meters. Okay, so the initial value, and then and then the rocket crash and dies. Yeah, all the time building that rocket, and then after launching it, it breaks.
Like when you know it's modeled by an equation, you know it's bad.
Yeah, so there's your broken rocket now. Okay, describe the transformations of this and sketch by mapping the rotations. Don't worry about like mapping rotations as long as you tell me where it ends up and the transformation, it's all good. Right, so vertex. What's my vertex here? Hazel? 3 and 4. Yeah. 3, 1, 2, 3, 4. There's my vertex. So the steps, my steps. So normally the steps are 1, 3, and 5, but my a value is -1/2. So I'm gonna multiply each of the steps by -1/2. So if it helps, you could even change this to a decimal. So you're going down half a step, going down 1.5 step, going down 2.5 steps. So you could do that too if it helps you visualize easier.
What's mapping notation?
Don't worry about that. All right, so from the vertex, I'm gonna go over 1 and down how many? How many blocks? Yep, half a box, right? So only right here.
Can't you just like multiply the length? That's what I did. I went like after 2 it goes down 4 blocks.
You could, but I think this way is less confusing. But if it works for you, it's okay too. Right? And then you go over 1 and then go down 1.5.
I think they want us to use like k over x plus d, ay plus c.
But then like this method, it only gives you more points. If you use the mapping notation, it will give you the same points. It's just this way. I think it's just the faster way. You don't have to map every single point in the original. Yeah. So, but like if you keep going with this, so then the next one would be 3.5 boxes. So 1, 2, 3. Wait. 1, 2, 3. So you see, you just end up getting the same points. You would have gotten this point, this point, this point, this point, and this point. What I did with the step method is I just gave 4 extra points, but it took it took less time. Okay. So any way that works for you guys to graph it. So I'm not marking on the method you use to create the graph. If you're stuck, do a table of value. I have no problem with that. As long as you can create a graph, it's good. Okay. So if for grade 11's sake, mapping notation means that you go from your original y equals x squared graph and then moving every single point to their new location. That's mapping notation. Okay, so the transformation. So what happened? That negative 1/2. What's the written description? Yep.
Vertical compression by a factor of half across the x-axis.
Okay, good. So the first of the negative tells you is reflected on the x-axis. A lot of people forget this, so make sure you don't. And then because it's a half, we know it's a compression. What did I say to you guys? To just say the compressed by 1/2 or by 2? What did I say to you? Just by half? Okay, compressed by a half.
You don't have to specify vertical horizontal compression.
No.
It's just compression by it.
Yeah. Okay. And then the minus 3?
That should be units to the right.
Right. So right by 3. And then the plus 4? Up 4. That's it. Okay. And when you do these mentally, you should also think, okay, yeah, it matches up with my graph. If you say reflected on the x-axis, but your graph opens upwards, you know you probably made a mistake somewhere. You probably missed something. Okay, so there you go. And since you said it's a compression, it should look a little wider than the normal y equals x squared. Okay. Last question in this package. Allison is flying a kite. She has released an entire 150-meter ball of kite string. So let's draw Allison. Since it's a girl, we'll give her a dress. Okay. She's flying a kite. So for those of you who flew a kite before knows that it looks like this. So the kite string, that's the string. That's the kite. Okay. That. Whee! Okay. That's the kite. She noticed that the string forms a 70-degree angle with the ground. So Allison is actually lying down on the ground. 70 degrees. Mark is on the other side of the kite. There's Mark right here with his pants. And then and he sights the kite at an angle of elevation of 30 degrees. Oops. Okay, so don't mind my trying. The 30 degrees and 70 degrees looks almost exactly the same. Yeah. So how far is Mark from Allison? So you're looking for this right here. Okay. Notice right here, I said that Mark is on the other side of the kite.
So no.
Yeah. So no ambiguous case. On the exam, no ambiguous case. Okay. So
There's no ambiguous case in the exam.
no.
Will there ever be ambiguous case ever again?
Grade 11. Yes, lots of ambiguous case. It's the whole chapter is ambiguous case. So. But now that you guys know how to do it, is that you guys will ace that chapter in grade 11, right? Yeah. Okay. So looking at this. Okay. There's a few different methods you could use to solve this. What method did you guys do? Elizabeth?
The angle of the kite.
You found the angle of the kite, yep. What is that angle? 80 degrees, because if this is 70, this is 30, that means what's left from 180? 80. Yep. And then what? Yeah, that's it. So this was the easiest way. You have a pair, and you know this angle, so you can find that side. If you found this instead, it's not wrong. You just went in a big circle. So if you did sine law and found that, you could then use that to help you do SOHCAHTOA to find this side leg, SOHCAHTOA to find this side leg, and then add them together. So it's not wrong. It was just a few more steps. Okay, but as long as at the end you get the same answer, it's fine. Math, there's tons of ways you can do a math questions. So this is the shortest way. So to set it up, 150 over sine 30 degrees equals x over sine 80 degrees. Alright, that's the sine law. Cross multiply and divide. So x equals 150 times sine 80 divided by sine 30. 150 times. By the way, when you guys do these questions, what's the most important thing to do before you attempt any of these type of questions?
Make sure your calculator's in degrees, not radians.
Yes, make sure it's in degree mode. Otherwise, you're just wasting your time. All right, and the worst part is you can't tell that you were wasting your time because you'll get an answer that you'll actually get an answer rather than like an error or something. So make sure it is in degree mode so that you didn't get the answers wrong. Okay. So what does it say to round to? Does it say? No, it doesn't say what to round to, so I'll just round to the nearest. So 295 meters. Okay. Okay, all good. Okay, so that was the first review package. As I said, I have that 20-page review package for you guys. I just killed some trees for you guys right here. All right. But to save some trees, not all trees, but some trees, I did 2 pages on one side. So it is quite small. You might need a magnifying glass, or you can look on Brightspace to, if it's too small for you to see the numbers, you can look on Brightspace to zoom in to see what it says. But otherwise, it does, you can see it, so that it's your package is not really 20 pages. It's more like 5. All right, so I'll give each of you a handout. Make sure you don't lose this, just like the first package. We will be working on this for the next few days. Let's see. So I would say we have half an hour left today. Let's do 20 pages. Let me do my math. How much do I want you guys to do? Okay, so why don't you guys start first, and then I'll tell you guys by the end of the period how much I want you guys to do up to. Okay, so keep doing. The more you guys do in class, the less I assign for homework. Sounds fair? Sounds weird, but it's fair.